Okay, we're going to go ahead and start going over these answers page by page. All right, so this first question is asking, please stop, is asking us to select all of the functions in which the output would be 6 if the input would be 16. So remember, output is the y value. Input is the x, right? So that's a really good, helpful hint right there. You're going to want to write that on your paper. And we have 1, 2, 3, 4, 5 different things we're evaluating. We have 5 different functions to determine. So it's not like multiple choice, it's which ones work. Okay, so if I were to do A, if my output is 6, does 6 equal 2 times 16 plus 4? Absolutely not, right? 6 does not equal 36. Okay. How about for B? Does 6 equal 16 times 10? Absolutely not. 6 does not equal 26, right? So far, we've got 2 no's. What about for C? Will 6 equal 16 minus 10? Yeah, absolutely. 6 equals 6. This would be a function. Okay? This would be the function that meets these requirements. How about down here for D? Remember, x is our input and y is our output. So when our output is 6, is our input 16? No, it's not, right? For this one, our output equals 6, input equals 8. So that's not what we're looking for. I went to my output and I went over the graph to find what my input would be. That's not a match. Okay? I needed my input to be 16 and it's not. Right? Sean, go ahead and close that up, please, and be paying attention. For this last one, if I go to my output of 6 and I go over to where it crosses x for my input, my output equals 6. My input is what?
16.
16, so this one works. Yes, sir?
Can we use this standard?
No. You can use it to help you prepare. Yep. Okay. So we have all these good pointers. Not just the answers, but we're actually filling in and giving ourselves pointers. Right? The older you get, the more you will start adding your own little thoughts and reminders to things to help you prepare. Let's go on to the next page. All right, we're doing another, where are the statements true? Okay, you guys are really good at this. Can someone remind me, what does this mean right here? These 2 little dash marks. What do these 2 little dash marks mean? Dexter?
Like telling you all the numbers from there up are going to be like spaced equivalently.
Perfect. We're going to have equal increments of 5 degrees, but we just didn't want to have to show 0 to 65 when all of our information is above 65. Okay, so we're just going to read these and say, are they true? Is temperature a function of time? Well, let's look at our graph. Temperature is our y value. Y value is also our output. Output is also our dependent variable. Right? Which makes time our x value, which is the same as saying our input, which is the same as saying independent value. And we've talked at length how the dependent variable is a function of the independent variable. So when I look at this, Is my dependent variable a function of my independent variable? They're saying temperature is a function of time. Is that true? So I want my dependent. Is temperature my dependent value? Yes. Is time my independent value? Yes. So this is true, right? Y is a function of X. My dependent
But it can't be a function because the line's not straight.
So the only reason it would not be a function is if one of my x values, one of my inputs repeated, right? So we're not looking for linear functions. We're just deciding is it a function. And if you remember, we have our vertical line test. Do you see how this would pass the vertical line test, Jace? Right? So this is true. How about this? The highest temperature occurred between 11 p.m. and midnight. Well, when I look at between 11 p.m. and midnight, is that the highest temperature on this graph? Nope. The temperature was increasing between 4 and 5 p.m. So when I look between 4 and 5 p.m., is this showing an increasing temperature? Nope. The temperature reached 70 degrees twice during the 12-hour period. Well, I have 70 degrees here, and I have 70 degrees here. So is that true? Yes. There was a 3-hour period during which the temperature steadily increased. Absolutely. Right? It actually is a 4-hour period, but we can say that there's a 3-hour window in there, right? So this does count as a 3-hour period because you can go from from noon to 3 or 1 to 4. Those are each 3-hour increments. Okay. Sean, put that away, please. Sean. Close your iPad for me. Thank you. Okay, next page. Slow and steady, like that turtle. Or no, like that tortoise. David?
This one I couldn't really find a good answer on.
That's okay. That's why we're going over it together. All right, Elena is going for a long walk. This shows the time she spent and the distance she traveled throughout the walk. What is her fastest speed? Okay, so we can determine how fast she's going because we have the distance she traveled in miles per hour, right? It's a very long walk. I mean, that's like a 9-hour walk. Someone might want to check on Elena, right? Okay, so if I'm trying to find her speed, I can use this window and I can use this window. Is she moving between hours 5 and 7? Excuse me, 4 and 7?
No.
Nope, she's hanging out somewhere, right? Maybe she went to the library and she's just chilling for 3 hours. I don't know. But this cannot count as her speed. So we're going to find what is her speed between the hours of 0 and 4, and what is her speed between the hours of 7 and 9. Okay, so I'm going to find my slope, right? So how many miles does she go? What is her vertical change?
5.
Here, so we have 5 over, up 5, and over 4 for her first speed, right? I'm going to use a marker for this, just so you guys can see it better. So for this first section, she goes up 5 and over 4. So that's how I get this slope. And if I simplify that, that's 1.25 miles per hour. Okay. And then for the second section, she goes 2 miles in 2 hours. So that's 1 mile per hour. So what's her fastest speed that she was actually moving.
1.2 miles per hour.
Yep. This is her fastest speed. So I looked at the graph and I found two sections where she was actually moving. What if part of this was, for whatever reason, the scenario, she's going down? Would that be a positive or negative speed?
Negative.
It's a negative slope, but speed can't be negative, right? She's not going back in time. So if for some reason the graph was decreasing, that would still give you a speed. It would just be she went in the opposite direction. Okay? We don't know what direction she went in, right? Maybe she went back, like she went away from her house and back to her house. We don't know. And then she hung out at her house and then she went away and back again really fast. Who knows? All right, next page. David, did that help you a little bit to see how we did that? Yeah. So you just find the two sections where it looks like she's moving and find the slopes, right? The biggest slope is going to be the fastest speed. All right, function. Function or not a function? We're going to determine whether each of these relationships is a function. Circle the correct option. Okay, so for this section of the assessment tomorrow, you literally just have to look at this scenario. Is it a function or not? Look at this scenario, function or not. Okay, so for A, in 2 minutes, Lynn read 1 page. In 4 minutes, she read 2 pages. And in 10 minutes, she read 5 pages. She continues reading at the same rate. Function or not a function? Mason? It is a function, right? The inputs do not repeat. Okay? It does not say in 2 minutes she read 6 pages and in 2 minutes she read 10 pages. That would not make sense, right? Inputs do not repeat. How about your height and your shoe size? Function or not a function? What do you think, Vlad?
Not function.
Why? Yeah, we have the red flag. What's our red flag? We have both 70s as our input, right? So let's write ourselves draw another little red flag. Okay. That means that 2 people were the same height, but they had different shoe sizes. We don't care that the shoe size is repeated. That doesn't matter to us. We're only looking at the X values to determine that. How about down here, number of pounds of bananas and the cost? Function or not a function? Isa?
Function.
It is a function. How do you know that? The X values do not repeat. Right? It passes the vertical line test. Okay. These are some ways that we know this is a function. Right? If I draw my pencil here, take it across the paper, it's going to pass the vertical line test. All right, look at this, moving right along. A kitten weighs 3.5 ounces at birth. After 1 day, its weight is 4 ounces. After 2 days, the weight is 4.5. On the next day, the weight is 5 ounces. Which quantity below represents the dependent variable? So which value depends on the other value? David? Yeah, the kitten's weight, right? I'm going to give you guys a hint in case you can't figure that out. Are you ready? If you look down at the graph that you would use, which one of these is the dependent variable? Right? Y is dependent. X is independent. What I would suggest is once you get the assessment tomorrow, go through and label all of your graphs. Y dependent, X independent. Put output and input if you need to. Help yourself out. So right here, now it says which quantity below represents the independent variable. I can look at my x-axis and say, oh, this is my independent variable, days since birth. Right? So a little cheat thing here is look at the graph. If you have committed to your memory that the y value is dependent and they give you a graph with it labeled, then you should know the title of the y-axis is going to be your dependent variable. Title of your x-axis is going to be your independent. Okay? Remember, you guys are dependents, right? This is what I tell my algebra kids. You guys are dependent on your parents, and you know what you ask them all the time? Why? Why, Mom? Why not? Why? Why? So that's another way to remember that dependent is you, and you are always asking your parents why. At least my children do. Right? It's another little way to keep in mind which is which. Let's go ahead and graph this. They described it up here. So we know that it was born, it was 3.5 ounces. After the first day, how much did it weigh? 4. After the next day, 4.5. Next day, 5. And then it says be sure to connect it. So you can go ahead and draw that line too. I'm sorry that it's kind of hard to see with the lights and the glares. There we go. Okay. Oh, I haven't looked yet. Third period did not. I will look before we're done here. We got just enough time. All right, Mai is purchasing rings and bracelets. Rings cost $1. Bracelets cost $2. She spends a total of $20. Let R represent the number of rings. Let B represent the number of bracelets. Let's create an equation relating the two variables. Anybody want to share the equation you came up with? What'd you come up with, Sean?
1b plus 2r equals 20.
You're so close. It's 1R plus 2B.
Sorry, I had switched.
It's okay. Equals 20, right? $1 per ring plus $2 per bracelet is going to give her $20. Now, this is where, and I wrote the B really weird so it doesn't look like a 6. Just deal with it. This is where it gets a little crazy. Which quantity represents the dependent value, Jace?
The 1R and 2B.
Okay, elaborate. I know what you're saying. Elaborate.
It's dependent because 20 is there. It is permanently there, so that means it's independent.
You're
But
so close. You're so close. What if I were to graph this? What if I wanted to graph this? What would be my x value? What would be my y value? It's kind of a trick question. It could be either, couldn't it?
Yeah,
It could go either way. You could say the ring depends on how many bracelets you buy. You could also say the bracelets depend on how many rings you buy. Which booth do you get to first, right? So when it asks which represents the dependent variable, you could really say either. So rings affect bracelets, or bracelets can affect rings. Right? What if you see the ring booth first? So you buy 6 rings. Well, that's going to then determine how many bracelets you can buy. What if you go the other way and you see the bracelets first? And you buy 8 bracelets? That's going to determine how many rings you can buy. Okay? So it's kind of a trick question. I don't love this question. But if you can explain to me why the one you choose works, you're going to be fine. Okay. Did anybody come up with a combination of rings and bracelets that can be purchased for $20? What did you come up with, Gail?
I said
10
10 rings and 5 bracelets.
rings and 5 bracelets. Absolutely, that would work. Vlad? 20 rings and no bracelets. They loved the ring booth. Yes.
4 rings and 7 bracelets.
Perfect. Yep. I think it would be 6 rings, right? And 7 bracelets. Because you want to spend the whole $20. You're not going home with money in your pocket, David. You're spending all the money. Right? Because seven bracelets will be $14. So if you get 6 rings, then it would add up to the 20. If you weren't sure how to do this, you could make a table. Rings, bracelets, and then total spent. And you could just do different combinations until you come up with one that equals the $20, right? So let's say I bought 3 rings. I only have $17 left. I can only buy 8 bracelets, but that's going to get me to 19. So that's not an option, right? So then maybe I try 4 rings. Then I can buy 8 bracelets, and that equals 20. So that could be an option, right? So I'm going to see a pattern where I'm going to need an even number of rings to buy an even number of bracelets, and then I can figure out and get to my $20. Okay, or it could be, I guess, an odd number of bracelets too. So any combination you come up with, it just needs to be that many rings plus that many bracelets will actually equal the $20. Okay, you could literally draw this on your assessment, and you'll circle the one that works, and that's how I'll know that's your answer. Okay. Did anybody solve it a different way? Did you just guess and check in your brain? What did you do? Mm-hmm.
I just put in like a certain amount for like the rings or bracelets and then just solved the equation.
Okay, so you use the equation from A. Good job. All right, number 7. How are we doing here? Whew, cutting it close. Okay, Andre plays wide receiver on his school football team. We're going to draw a graph of this. Okay, now notice that this graph down here has no increments. You're going to want to give yourself some increments. So I did 2-second intervals. And 1-yard intervals. And then I just looked at the different pieces and created the graph. It says when it starts, he ran forward 4 yards. I don't know how long it's going to take him, but I'm just going to make sure he goes forward 4 yards. Maybe it only takes him 2 seconds. So your graph might not look identical to mine. Remember, we did this on Friday? They might not match up. It just has to meet the requirements. Then he stood in that spot for 6 seconds. So I'm just going to show him not moving for 6 seconds, a horizontal line. Then he ran forward 2 more yards. Maybe it only takes him 2 seconds to go 2 yards this time. And finally, he walked back to where he began. So anywhere I end up, then this last one's going to go all the way back to where he began. So it should look vaguely like mine. You shouldn't have any turnarounds, right? Your increments have to be the 4 and the 2, and you need to have the 6 seconds. Okay? All right. We will go over number 8 before you take the quiz tomorrow. We will go over number 8 before you take the quiz tomorrow.
It's literally the one with questions. I mean, do you